This lecture is prepared for the PLM Raha ROTC unit. Good day, cadets. Our topic for this video is basic map reading and land navigation. Before the discussion, let me introduce myself. I am First Lieutenant Jose Carriaga, Reserve Philippine Army. I am a member of the 105th Task Group, 1st Task Brigade, Reserve NCR, under the AFP Reserve Command, a BS Mechanical Engineering graduate, and work at the Department of Engineering and Public Works, City of Manila. Maps and their substitute are of particular value to the military establishment. It is frequently necessary to identify ridges, alleys, route of movement, and other characteristics of section of terrain that can be reconnoitered in advance. Plans for future operations must be based on knowledge gained in part from maps and their substitute. Therefore, as future member of the AFP, you must know how to use and read map. It is mandatory for you to know the meaning and importance of a map. The primary objective of this lesson is to enable you to read map and apply the theories, principles, and techniques that are considered essential in the total development of small unit leaders. One important fact to consider is that the finest map made in the world is practically useless unless the user knows how to read and use it. Topographic products such as maps provide the tools that the combat leader needs to visualize the battlefield and make sound decisions. The ability to visualize the terrain is vital to success of military operations. It is essential that you as a combat leader understand and fully utilize topographic products available to expand your vision and see all you can see of the terrain. Let us first define the map. A map is a graphic representation of a portion of the Earth's surface drawn to scale. It is also a documentation of events and phenomena that affects the land surface. It uses colors, symbols, and labels to represent features found on the ground. A map could be compared to any piece of equipment in that before it is placed into operation, the user must read the instructions. It is important that you as a soldier know how to read these instructions. The most logical place to begin is the marginal information and symbols, where useful information telling about the map is located and explained. All maps are not the same, so it becomes necessary every time a different map is used to examine the marginal information carefully. Sheet name is the title of the map and named after the largest geographical area presented. The sheet name is found in bold print at the center of the top and in the lower left area of the map margin. Sheet number used as a reference number for the map sheet. The sheet number is found in a bold print in both the upper right and lower left areas of the margins and in the center box of the adjoining sheets diagram, which is found in the lower right margin. Series name. The name given to the series is generally that of a major political subdivision, usually includes a group of similar maps to cover a particular geographic area. The map series name is found in the same bold print as the sheet number in the upper left corner of the margin. Scale. A representative fraction that gives the ratio of a map distance to the corresponding distance on the Earth's surface. The scale is found both in the upper left margin after the series name and in the center of the lower margin. The scale note is a representative fraction that gives the ratio of a map distance to the corresponding distance on the Earth's surface. Series number. A sequence reference expressed either as a 4-digit or as a letter, followed by a 3 or 4-digit numeral. The series number is found in both the upper right margin and the lower left margin. Edition number. Editions are numbered consecutively. The highest numbered sheet is the most recent. The edition number is found in the bold print in the upper right area of the top margin and the lower left area of the bottom margin. Index to boundaries is a miniature of the map that shows the boundaries that occur with the map area, such as provincial and city boundaries. The index to boundaries diagrams appears in the lower or right margins of all sheets. Adjoining sheets diagram. usually contains 9 rectangles that represent the adjoining sheets surrounding the map represented. Sheets are identified by their sheets number. Declination diagram indicates the angular relationship of true north, grid north, and magnetic north. This is located in the lower margin of a large scale maps and indicates the angular relationship of the true north, grid north, and magnetic north. Ideally, diagram can be used within 5 years from date imprinted herein. Bar scale. Rulers used to convert map distance to ground distance. These are located in the center of the lower margin. Contour interval note states the vertical distance between adjacent contour lines of the map. This note is found in the center of the lower margin normal below the bar scale. Grid reference box contains instructions for composing a grid reference. This box is normally located in the center of the lower margin. Unit imprint and symbol identifies the agency that prepared and printed the map with its respective symbol, important to the map user in evaluating the reliability of the map. The unit imprint and symbol is on the left side of the lower margin. Legend illustrates and identifies the topographic symbols used to depict some of the more prominent features on the map. The symbols are not always the same on every map. The legend is located in the lower left margin. Colors used on a military map. Black indicates cultural man-made features such as buildings and roads, salvage spot elevation, and all labels. Red-brown. The colors red and brown are combined to identify cultural features or relief features, non-surveyed spot elevations, and elevations such as contour lines on red light readable maps. Blue identifies hydrography or water features such as lakes, swamps, rivers, and drainage. Features that constitute obstacles are included in this group. Green identifies vegetation with military significance such as woods, orchards, and vineyards. They are features that will affect troop movement. Brown identifies or relief features and elevation such as contours on older edition maps and cultivated land on red light readable maps. Red classifies cultural features such as populated areas, main roads, and boundaries. Purple indicates new information superimposed on an existing map. Sometimes maps with this color are referred to as magenta map. Other. Occasionally, other colors may be used to show special information indicated in the marginal information as a rule. Military symbols. In addition to the topographic symbols used to represent the natural and man-made features of the earth, military personnel require some method for showing identity, size, location, or movement of soldiers and military activities and installations. Here are the different basic military symbols. Orientation of map. A map is oriented when in a horizontal position and each north and all map lines are parallel to their corresponding lines on the ground. There are different methods for map orientation. Orientation by using compass. Compasses are the primary navigation tools to use when moving in an outdoor world where there is no other way to find directions. There are different types of compasses. The lensatic compass is the most common and simplest instrument for measuring direction. It is also used for land navigation. The lensatic compass is composed of three major parts: the cover, which protects the floating dial, the base contains the movable parts of the body, and the lens that is used to read the dial. The process by using the compass. Place the map on a flat surface and draw the magnetic north line using the pivot protractor on the map. Place the open compass over the magnetic north line in such towards the top of the map and is directly over the magnetic line that has been drawn. Turn the map counterclockwise, taking care not to move the compass from its position over the magnetic north line until the needle align under the index line of the compass. Another method, by means of inspection, using the roads, streets, and other identifying features both on the map and in the ground. Look around you for some recognizable features such as road. Move the map until the road on each parallel to the road on the ground. This not only orient the map but also it orients you. Next, by means of analog watch, get a piece of small stick. Place the shadow of the stick in line hour hand of the watch. From the distance of the hour and the minute hand, divide it into two, the center of it, and get the direction. By means of twig shadow, get a piece of twig, plant it down to make an angle that will produce a shadow, and mark the first shadow aligned to it. After an hour, the shadow will move, then make the line on the next shadow. It will tell the east and west direction and also the north and south direction. The other method is by reference landmark. The landmark may also tell the position on the map. It always tells the position of the map if the two known features is present on the map. The last by reference during night operations. Locate the North Star, the Southern Cross, the moon, and look at the direction of the trees. Military maps are categorized by scale and types. Map categories by type. Planimetric map. This is a map that presents only the horizontal positions for the features represented. It is distinguished from the topographic map by the mission of relief, normally represented by contour lines. Sometimes it is called a line map. Topographical map. This is a map that portrays terrain features in a measurable way, as well as the horizontal positions of the features represented. The vertical positions or relief are normally represented by contour lines on military topographic maps. On maps showing relief, the elevation and contours are measured from a specific vertical datum plane, usually mean sea level. Photo map. This is a reproduction of an aerial photograph upon which grid lines, marginal data, place names, route numbers, important elevations, boundaries, and approximate scale and directions have been added. Terrain model. This is a scale model of the terrain showing features, and in large-scale models showing industrial and cultural shapes. It provides a means for visualizing the terrain, for planning or indoctrination purposes, and for briefing on assault landings. Military city map. This is a topographic map, usually at 1:12,550 scale, sometimes up to 1:5,000, showing the details of a city. It delineates streets and shows street names, important buildings, and other elements of the urban landscape important to navigation and military operations in urban terrain. The scale of a military city map depends on the importance and size of the city, density of detail, and available intelligence information. Special map. These are maps for special purposes such as trafficability, communication, and assault maps. They are usually in the form of an overprint in the scales smaller than 1:100,000 but larger than 1:1,000,000. A special purpose map is one that has been designed or modified to give information not covered on a standard map. Military maps categorized by scale. The mathematical scale of a map is the ratio or fraction between the distance on a map and the corresponding distance on the surface of the Earth. Representative fraction or scale is equal to map distance over ground distance, as the denominator of the RF or the representative fraction gets larger and the ratio gets smaller, the scale of the map decreases. Small scale, those maps with scale of 1:1,000,000 and smaller are used for general planning and for strategic studies. Medium scale, those maps with scales larger than 1:1,000,000 but smaller than 1:75,000 are used for operational planning. The standard medium scale map is 1:250,000. Large scale, those maps with scales of 1:75,000 and larger are used for tactical, administrative, and logistical planning. Ground scale can be determined from a map by the scale. Scale is the relation between distance on the map and actual distance on the ground. It is expressed on one or more of the following ways: work and figures. Scale may be expressed by a simple statement like 3 inches equals 1 mile, meaning 3 inches on the map equals 1 mile on the ground. Similarly, 1 inch equals 200 feet, meaning 1 inch on the map equals 200 on the ground. Representative fraction, RF. The representative fraction formula is RF equals map distance over ground distance, in which the numerator and denominator are expressed in the same unit as inches, feet, yards, meters, or miles. The RF appearing in the margin as 1:20,000 such unit on the ground. The larger the denominator of the RF, the smaller the scale of the map. Thus, a 1:100,000 map is a small scale map, and 1:20,000 is larger scale map. Example, the map scale is 1:50,000. The representative fraction or RF equals 1/50,000. The map distance from point A to point B is 5 units. To get the ground distance, 5 times 50,000 equals 250,000 units. Graphic scale. Distance may also be measured by a graphic scale, a special ruler for the particular map printed in the margin. Conversion factor. Distance may be expressed in either the English or the metric system, and it may be necessary to convert measurement of the system with those of another. Direction. Being in the right place at the prescribed time is necessary to successfully accomplish military missions. Directions plays an important role in a soldier's everyday life. Methods of expressing direction. Military personnel need a way of expressing direction that is accurate, is adaptable to any part of the world, hence has no common unit of measure. Directions are expressed as units of angular measure. The most common unit of measure is the degree, with its subdivisions of minutes and seconds. 1 degree is equal to 60 minutes. 1 minute is equals to 60 seconds. Another unit of measure. The mil is used mainly in artillery, tank, and mortar gunnery. The grad is a metric unit of measure found on some foreign maps. There are 400 grads in a circle. The grad is divided into 100 centesimal minutes and the minute into 100 centesimal seconds. Baselines. In order to measure something, there must always be a starting point or zero measurement. Direction from one point to another is always expressed as an angle from the baseline. There are 3 phases directions, namely true north, magnetic north, and grid north. True north, a line from any point on the Earth's surface to the North Pole. All lines of longitude are the true north lines. True north is usually presented by star. Magnetic north, the direction to the north magnetic pole as indicated by the north-seeking needle of a magnetic instrument. Magnetic north is usually symbolized by a line ending with a half arrowhead. Magnetic readings are obtained with magnetic instruments such as Lensatic and M2 compasses. The grid north that is established by using the vertical grid lines on the map. Grid north may be symbolized by the letters GN or the letter Y. Azimuth. An azimuth is defined as a horizontal angle measured clockwise from a north baseline. This north baseline could be true north, magnetic north, or grid north. The azimuth is the most common military method to express direction. Back azimuth. A back azimuth is the opposite direction of an azimuth. It is comparable to doing an about face. To obtain a back azimuth from an azimuth, add 180 degrees if the azimuth is 180 degrees or less, or subtract 180 degrees if the azimuth is 180 degrees or more. The back azimuth of 180 degrees may be stated as 0 or 360 degrees. The magnetic azimuth is determined by using magnetic instruments such as Lensatic and M2 compasses. Grid azimuths. When an azimuth is plotted on a map between point A and point B, the points are joined together by a straight line. A protractor is used to measure the angle between grid north and the drawn line, and this measured azimuth is the grid azimuth. Declination diagram is the angular difference between any two norths. If you have a map and a compass, the one of most interest to you will be between magnetic and grid north. Location. A declination diagram is a part of the information in the lower margin on most larger maps. On medium scale maps, the declination information is shown by a note in the map margin. The grid magnetic angle or the GM angle value is the angular size that exists between grid north and magnetic north. It is an arc indicated by a dashed line that connects the grid north and magnetic north prongs. Grid convergence. An arc indicated by a dashed line connects the prongs for true north and grid north. Conversion. There is an angular difference between the grid north and the magnetic north. Since the location of magnetic north does not correspond exactly with the grid north lines on the maps, a conversion from magnetic to grid or vice versa is needed. The inclusion of the true north prong in relationship to the conversion is of little importance. Applications. Remember, there are no negative azimuths on the azimuth circle. Since 0 is the same as 360 degrees, then 2 degrees is the same as 362 degrees. This is because 2 degrees and 362 degrees are located at the same point on the azimuth circle. The grid azimuth can now be converted into a magnetic azimuth because the grid azimuth is now larger than the grid magnetic angle. When working with a map having an east grid magnetic angle, let's start to plot a magnetic azimuth on a map. First, change it to a grid azimuth. To use a magnetic azimuth in the field with a compass, first change the grid azimuth plotted on a map to a magnetic azimuth. Convert grid azimuth to a magnetic azimuth when the GM angle is greater than a grid azimuth. To plot a magnetic azimuth on a map, first convert it to grid azimuth. To use a magnetic azimuth in the field with a compass, change the grid azimuth plotted on a map to a magnetic azimuth. Convert a magnetic azimuth when the grid magnetic angle is greater than the magnetic azimuth. Intersection. Intersection is the location of an unknown point by successively occupying at least two known positions on the ground and then map sighting on the unknown location. When using the map and compass method, orient the map using the compass. Locate and mark your position on the map. Determine the magnetic azimuth to the unknown position using the compass. Convert the magnetic azimuth to grid azimuth. Draw a line on the map from your position on this grid azimuth. Move to a second known point and repeat. The location of the unknown position is where the lines cross on the map. Determine the grid coordinates to the desired accuracy. The straight edge method is used when a compass is not available. When using it, orient the map on a flat surface by the terrain association method. Locate and mark your position on the map. Lay a straight edge on the map with one end at the user's position as a pivot point. Rotate the straight edge until the known point is sighted along the edge. Draw a line along the straight edge. Repeat steps at position and check for accuracy. The intersection of the lines on the map is the location of the unknown point. Determine the grid coordinates to the desired accuracy. Resection. Resection is the method of locating one's position on a map by determining the grid azimuth to at least two well-defined locations that can be pinpointed on the map. For greater accuracy, the desired method of resection will be to use 3 or more well-defined locations. When using the map and compass method, orient the map using the compass. Identify 2 or 3 known distant locations on the ground and mark them on the map. Measure the magnetic azimuth to one of the known positions from your location using a compass. Convert the magnetic azimuth to a grid azimuth. Convert the grid azimuth to a back azimuth using a protractor. Draw a line for the back azimuth on the map from the known position back toward your unknown position. Repeat for a second position and a third position if desired. The intersection of the lines is your location. Determine the grid coordinates to the desired accuracy. When using the straight edge method, orient the map on a flat surface by the terrain association method. Locate at least 2 known distant locations or prominent features on the ground and mark them on the map. Lay a straight edge on the map using a known position as a pivot point. Rotate the straight edge until the known position on the map is aligned with the known position on the ground. Draw a line along the straight edge away from the known position on the ground toward your position. Repeat using a second known position. The intersection of the lines on the map is your location. Determine the grid coordinates to the desired accuracy. Modified resection. Modified resection is the method of locating one's position on the map when the person is located on a linear feature on the ground, such as road, canal, or stream. Orient the map using compass or by terrain association. Find a distant point that can be identified on the ground and on the map. Determine the magnetic azimuth from your location to the distant known point. Convert the magnetic azimuth to a grid azimuth. Convert the grid azimuth to a back azimuth using a protractor. Draw a line for the back azimuth on the map from the known position back toward your unknown position. The location of the users is where the line crosses the linear feature. Determine the grid coordinates to the desired accuracy. Polar coordinates, a method of locating or plotting an unknown position from a known point by giving a direction and a distance along the direction line, is called polar coordinates. The following elements must be present when using polar coordinates. Present known location on the map, azimuth, and distance. Grids is to determine and report position on the ground in terms of their locations on a map. Reference system. In a city, it is quite simple to find a location. The streets are named and the buildings have numbers. The only thing needed is the address. However, finding locations in undeveloped areas or in unfamiliar parts of the country can be a problem. To cope with this problem, a uniform and precise system of referencing has been developed. Geographic coordinates, one of the oldest systematic methods of location, is based upon the geographic coordinate system by drawing a set of east-west rings around the globe and a set of north-south rings crossing the equator at right angles and converging at the poles. A network of reference lines is formed from which any point on the Earth's surface can be located. Military grids, an examination of the transverse Mercator projection, which is used for a large-scale military maps, shows the most lines of latitude and longitude are curved lines. Grid squares, the north-south and east-west grid lines intersect at 90 degrees, forming grid squares. Normally, the size of One of these grid squares on large-scale maps is 1,000 meters by 1,000 meters. Grid coordinates scales. The primary tool for plotting grid coordinates is the grid coordinate scale. The grid coordinate scale divides the grid square more accurately than can be done by estimation, and the results are more consistent. When used correctly, it presents less chance for making errors. GTA or Graphic Training Aid contains 4 types of coordinate scales. Locating a point using grid coordinates based on the military principle for reading maps, locations on the map can be determined by grid coordinates. By the way, the cardinal rule in getting grid coordinates is the read, write, and up. Special care should be exercised when recording and reporting coordinates. Transposing numbers or making errors could be detrimental to military operation. Locating a point 10,000 meters square, the breakdown of the grid reference system continues as each side of the 100,000 meters square is divided into 10 equal parts. 1,000 meters square. To obtain 1,000 meters squares, each side of the 10,000 meters square is divided into 10 equal parts. This division appears on large-scale maps as the actual grid lines. They are 1,000 meters apart. 100-meter identification. To locate to the nearest 100 meters, the grid coordinate scale can be used to divide the 1,000-meter grid squares into 10 equal parts. 10-meter identification. The grid coordinate scale has divisions every 50 meters on the 1:50,000 scale and every 20 meters on the 1:25,000 scale. This can be used to estimate to the nearest 10 meters and give the location of one point on the Earth's surface to the nearest 10 meters. Accuracy. The accuracy of a point location is shown by the number of digits in the coordinates. The more digits, the more accurate the location. Military grid systems, it is a network of square formed by north, south, and east-west grid lines placed on the map. The 4 digits to the nearest 1,000 meters, 6 digits to the nearest 100 meters, the 8 digits to the nearest 10 meters, and the 10 digits to the nearest 1 meters. That's for the basic map reading and land navigation. As a reminder, a map provides information on the existence, the location of, and the distance between ground features such as populated places and routes of travel and communication. It also indicates variations in terrain, heights of natural features, and the extent of vegetation cover. With our military units dispersed throughout the country, it is necessary to rely on maps to provide information to our combat elements and to support tactical and strategic operations. Soldiers and material must be transported. To be understandable, features must be represented by conventional signs and symbols. The portrayal of many features requires similar exaggeration. Therefore, both the selection of features to be shown as well as their portrayal is in accord with the product specifications adhered to by the Armed Forces Topographic Unit. Thank you and good day. Keep safe.